Welcome. In this lesson, I want to help you understand what it means to be the opposite side of an angle, or how to find the opposite side of an angle, how to find the adjacent side to an angle, and obviously the hypotenuse of right triangles. So these all deal with right triangles. That's one thing that's very, very important to realize, is that these must be right triangles. And so we know they're right triangles because all right triangles should have a little square in one of the corners. One corner is a square corner, right, at a 90-degree angle. Now, the first thing I want to emphasize is how we find the hypotenuse. The hypotenuse is always the side that is not part of the right angle. There's two sides that form the right angle. So the hypotenuse, and this is the way you would write it, is side AB with a line above it. That basically means line segment AB is the hypotenuse of this triangle. Now, there are two other angles that are not right angles. They're acute angles. Acute angle A, which is this angle here, and angle B, which is this angle up here. And they're different sizes. They're not necessarily the same size. Now, we will often want to know what the opposite side of angle A is. Well, the opposite side of angle A is the side that's formed by connecting the two angles or vertices that are not A. So BC, side BC, would be the opposite side of angle A. I like to just think, hey, I got to go across that triangle to get to that side. If I wanted to be on this side here, I wouldn't have to go anywhere, or this side here, I wouldn't have to go anywhere. But to get to side BC, I have to go all the way to the opposite side of the triangle to get from A to side BC. But what if I want the adjacent side to angle A? Now, the most important thing to remember about the adjacent side is it's never the hypotenuse. The adjacent side is never the hypotenuse. The adjacent side is the side that connects angle A, the angle we're looking at, with the right angle. So for this one, it would be C. So the adjacent side would be side AC when it comes to angle A. The adjacent side to angle A is AC because it connects A to the right angle. Now, if I was to change and talk about the other acute angle, angle B up here, what's the opposite side of angle B? Well, the opposite side of angle B, again, is I'm going to go across the triangle, or it's going to be the side that connects the two vertices that are not B. So the other two vertices are A and C, so the side opposite B would be the side AC. If I wanted the adjacent side to angle B, the adjacent side to angle B is always the angle itself connected to the right angle, the little square. So I'm going to go from B down to C, or its side BC would be the adjacent side to angle B. So you'll notice it changes. For A, the opposite side is BC, but for angle B, BC is the adjacent side. It depends on which angle you're looking at. Now, I want to emphasize that the triangles don't have to be in any particular orientation. This one's a little different. It's triangle XYZ, which I meant to do. So now I fixed the double Y. So now we have an XYZ triangle, but where's the right angle? The right angle's at the top. So I always recommend find the hypotenuse first. Now remember, the hypotenuse is the side that isn't part of the right angle. XY forms this right angle and YZ forms the right angle. It's XZ that doesn't. So if I was to write down the side that's the hypotenuse, I would say it's side XZ is the hypotenuse. Now I'm going to come over here and say, what's the opposite of angle X? Now again, we're always going to find the opposite and adjacent of the two acute angles, never the right angle, at least not yet, not today. But we're going to find the opposite side of X. X is an acute angle. Well, the opposite side of X, again, is the side that is formed by the two vertices that are not X. So I go to Y and Z, it's this side here. So the opposite side of X is the side YZ. But what's the adjacent side of x. The adjacent side is going to be the side that includes x that goes towards the right angle, never the other acute angle, not the hypotenuse. Again, the adjacent sides are never the hypotenuse. So I go from x to the right angle, that's xy. So the adjacent side to x is the side xy. Now, what would I get if I wanted to find the opposite side of angle z? Well, again, the opposite side of angle, or opposite side of angle z is going to be this side over here that forms by x and y being connected. X and y are the two vertices that are not part of z, and that forms the opposite side. Now again, the adjacent side, it's never the side that's the hypotenuse. It's never the side connecting the two acute angles. It's always the adjacent side will always include the angle that you're starting from, so angle z, and it goes towards the right angle. So it would be the side zy. Now, one last thing I want to emphasize is it really doesn't matter the order the two letters are in. So I could say the adjacent side is the side YZ. The order of the two letters don't really matter, but it is important that you do the right two letters. So this could be side YX would be fine. Hypotenuse could be ZX, that would be fine. The opposite side of angle X would be ZY is fine, or YZ. As long as you use the right two variables, the right two letters, you get that down. So just remember, opposite side is the side that's formed by the two vertices that's not the angle we're looking at. The adjacent side is the side of the, with the angle we're looking at along that side to the right angle. So if I'm looking at angle Z, the adjacent side would go from Z to the right angle, so ZY or YZ. Again, the order doesn't matter. And the hypotenuse is always the side that isn't one that forms the right angle. So you have the two sides that form the right angle, the hypotenuse doesn't. Again, if you have any questions, please do bring them to class, and I